Okay, this is 2.6 modeling with functions. This is day 1. I have a woman 5 feet tall is standing near a street lamp that is 12 feet tall, as shown in the figure below. Find a function that models the length of her shadow in terms of her distance d from the base of the lamp. Now, I know a lot of you may not want to do this, but I'm going to go ahead and do so. I've got the woman 5 feet tall. The length is L. Then I have my second triangle that's going to help out. I've got a lamppost that's 12. This length down here is going to be L plus my D. Now it's going to be really easy to set up a proportion. This is going to be 5 over L is equal to 12 over L plus T. Now we can cross multiply. That gives me 5L plus 5D, and that equals to 12L. Let's solve for L. So let's see, this is 5D is equal to 7L, and so L is equal to 5 over 7D, and that should be little l. Okay, moving on. A gardener has 140 feet of fencing to fence a rectangular vegetable garden. What is the maximum area that she can fence? Define your variables and write an equation for what you are trying to maximize. Okay, so first of all, I know that I have perimeter, and that's 140 feet. I have a rectangular garden. Go about with length times width. So I know that each side could be 35, but that's kind of odd. So how about we go with, if I go length and width, then I could say that this is 70 minus an unknown, and this could be my unknown. Or I could have done the width here as 70 minus x. All right, so this is how I came about with it. I know it's 140. So now if I know that, write another equation using the other given information and solve the equation for one variable. So now I know, given my perimeter, that twice my length plus twice my width is 140. If I were to solve for one of those, how about we solve for length? So twice length equals 140 minus twice width. So your length is 70 minus your width. Okay, what if you solved for width? Twice width equals 140 minus twice length. So your width is 70 minus your length. Okay, so those are the same. It kind of looks like the, whoops. It looks just like what I came up with here. Okay, so I could replace that with an X, and those would be exactly the same. Let's say that. Doesn't matter which one I use. Okay, let's see what else we can do with this. Write an equation of the quantity you are trying to maximize in terms of a single variable. Okay, so that's why I changed them to an X so that I have a single variable. So how about let's go back to my area formula. So that's length times width. So no matter which one of these formulas or length or width that I use, if I plug that in, length or width is X. The other one is 70 minus X. Okay. Find the maximum area of the garden. So now I can use my calculator. And I'm not going to show you that, so I hope that you have that out. I can go to Y1, and I can plug this in, X times 70 minus X. Graph this, and it says find the maximum. So I'm going to just go in and look for the maximum. So this should be a parabola since you have an X times an X. And I want you to find the maximum. The maximum should be 35, 1,225. Now we just need to interpret that. So if one of them is 35, so if your length or width is 35, that would be 35 feet. Then of course your width, which is 70 minus, is also 35. Not much of a rectangle here. It says always check to make sure your answers are in the domain of the problem. And it says find the maximum area. So my maximum area here is, and it goes ahead and tells you, 1,225 square feet. All right, let's move on. So a hockey team plays in an arena with a seating capacity of 15,000 spectators. With a ticket price set at $14, the average attendance at a recent game has been 9,500. A market survey indicates that for each dollar the price is lowered, the average attendance will increase by 1,000. Find a ticket price that will maximize your revenue. All right. What I'm thinking here is, first of all, that you're going to think of, or what I think of, is we're going to say ticket price is going to be multiplied by your attendance. Because when you go, you're going to have to buy a ticket. Okay. So what is our X value going to be? How about we say this is going to be how much, it said how much our money is, oh, there it is. Each dollar the price is lowered. So our money lowered. Okay, so how much are we going to be? Our maximum revenue. Let's start thinking of an equation. So it said, excuse me, that we start with $14. So every $14, it said that our price is going to lower. We're going to multiply that by our attendance. What do we know about our attendance? It says that in recent games there has been 9,500 people at the game. So let's start with that. And what do we know about those people? Well, it says that they're going to increase by 1,000. So are we just going to take our people and add 1,000? Do we need to do anything about that? Well, I think that we need to multiply that by the ticket price as well. We're going to increase the average attendance will increase by 1,000. Okay, at this point, you can go ahead and use your calculator. So I would say plug this in to Y1 again. It says you're going to find your maximum. So go in here and you're going to look for your maximum. So again, you've got an X times an X, so this should be a parabola. So from this, your maximum should be 2.25, comma, this is a 13806.25. So we just need to interpret this right here. Find the ticket price, okay? So our ticket price, now remember right here, this was our ticket price, was $14, and it keeps decreasing, and it's decreasing by 2.25. So I'm going to say $14 minus the $2. $14 minus the $2.25. So our ticket price is $11.75. And then the maximum revenue from this ticket sales is right here. So the maximum revenue is given. $0.25 there. Okay. Last problem. A manufacturer makes a metal can that holds 1 liter of oil. What radius maximizes the amount of metal used to make a can? What is the minimum surface area? And label your units. And they gave you that 1 liter is 1,000 centimeters. I think this should be cubed. Okay, so we're starting with volume, and then they go to surface area. They told you 1 liter of oil is this. And so it looks like I'm going to start with this volume formula right here. If I know that 1 liter of oil, I think this is your volume. But instead of talking about 1 liter, they gave you 1 liter is 1,000 centimeters. So I'm going to go ahead and plug in my my 1,000 here. So I'm going to say that volume is 1,000 is equal to pi, and that's r squared h. Okay, this doesn't help me very much when I'm talking about my surface area. So how about we go ahead and solve for h. So if I solve for h, that's going to give me 1,000 over the pi r squared. And then since I have h, I can substitute it into my formula over here. So now let's go to surface area. And that gives me 2 pi r squared plus 2 pi r. and I'm going to plug in my h, which is 1,000 over pi r squared. Now realistically, these pi's cancel and one of the r's cancel. If you would like to do that, you can. If you don't want to, you can plug this straight into your calculator again into y1. So that's what I want you to do. It looks like we're looking for a minimum. So go ahead and look for your minimum. And I came up with 5.419 and 553.581. We need to interpret this. So it says, what is the radius? Minimizes the amount of metal, and what is the minimum surface area? So the first one is going to be your radius. So this is going to be 5.419 centimeters, and this is your radius. And the next one is going to be your surface area. So this is 553.581 centimeters squared, and this is your surface area. Since it's surface area, it's squared. Okay, this is it.